Итак, уважаемые участники, мы начинаем пленарное заседание Международного научного форума Ломоносов. И от лица декана геологического факультета, который сегодня по уважительной причине не может присутствовать, я поздравляю всех участников, организаторов нашего форума с непростым, но все-таки началом конференции. Сразу хочу сказать, что конференция наша проходит далеко не первый год и уже даже не 10 лет. Она традиционная и она весенняя. В университете традиция проводить весенние конференции молодежные и для больших ученых. Ломоносовские чтения, которым уже много десятков лет, студенческая молодежная конференция Ломоносов всегда традиционно проходит в апреле, но в этом году она проходит позже. Причины всем понятны, и не так плохо на самом деле, что мы сейчас в ноябре, в этот предзимний день здесь собрались. Почему неплохо? Ну, во-первых, хорошо, что мы в принципе смогли провести эту конференцию. Во-вторых, у нас участвуют в основном студенты, и в основном студенты, которые в мае-июне защищали свои дипломные работы. И если в апреле дипломные работы только находились в начальном зачаточном состоянии их написания, то после защит вы обкатали свои дипломы, и сейчас мы сможем заслушать уже законченные работы, как бакалаврские, так и некогда магистерские. У вас почти у всех был нормальный полный полевой сезон, вы собрали материал. Многие молодые участники, которые еще не писали и не защищали дипломных работ, впервые прошли производственные практики и смогли, обобщив материал своих производственных практик, подготовить доклады, которые мы все с удовольствием выслушаем. Поэтому не так плохо, что в итоге мы в этом году собираемся в ноябре. Доклады будут более полные, докладов будет больше. И что самое интересное, мы с апреля по ноябрь, в общем-то, все привыкли к дистанционному видеоформату конференций. Если в апреле мы переспрашивали через слово, слышно нас или нет, и выглядели на экране достаточно комично, то сейчас все уже и участники, и организаторы совершенно свободно общаются через все возможные средства видеоконференций. И, как показали защиты, которые прошли в конце мая, в начале июня, для многих процедура видеоконференции гораздо более комфортно, чем очно стоять у доски. Я имею в виду, конечно, наших молодых коллег. Проведенные соцопросы студентов и преподавателей показали, что именно для защит, для выступлений, для конференций этот режим максимально комфортен. Поэтому, в принципе, одни плюсы и минусов я пока не вижу. Таким образом, у нас сейчас с вами состоится пленарное заседание. К 10 часам, может быть, чуть позже, начнутся секционные, и мы будем слушать доклады самого разного уровня из разных стран мира. У нас несколько международных участников. Мы будем слушать там доклады как на русском, так и на английском языках. Мы будем слушать разные доклады по уровню. Кто-то первый раз в жизни выйдет на большую научную аудиторию, я имею в виду бывших студентов 3-го, нынешнего 4-го курсов разных университетов, не только МГУ. Много будет ребят, которые защищали бакалаврские дипломы, будут бывшие магистры, будут нынешние аспиранты. У нас будут разные доклады абсолютно. У нас будут смешанные секции. На секции геофизики будут выступать инженер-геологи и наоборот. И ничего в этом страшного нету. Почему? Потому что все мы здесь собрались по одной единственной причине. Мы хотим рассказать и доложить друг другу результаты своих научных достижений. У кого-то они первые, у кого-то нет, но мы все объединены как бы одной целью. Поскольку мы все находимся на секции «Геология», молодежный форум Ломоносов, значит, мы все любим геологию и хотим поделиться друг с другом результатом своих научных изысканий. Я призываю всех коллег, а на конференции мы все коллеги. Тут нет студентов младших, старших курсов, преподавателей, либо маститых ученых. Мы все в той или иной мере ученые. Кто постарше, кто помоложе. Ранг у всех разный, но мы все ученые. Мы все равны. Мы слушаем друг друга, мы не боимся. Мы не ставим друг другу оценок, не выносим друг другу каких-либо решений. Мы рассказываем о своей науке, о своем поиске, о своем эксперименте, смело рассказываем, ничего не боимся, отвечаем на вопросы, вопросы задаем максимально корректно. Преподавателей учить не надо, они все это без этого знают прекрасно. Я про молодежь. Не бойтесь участвовать, не бойтесь задавать вопросы. Для многих это ваша первая научная конференция, но, естественно, не последняя. Вот. И я поздравляю всех нас с тем, что мы собрались. Я поздравляю всех нас, что мы геологи, любим геологию и хотим рассказать про свою науку. И я уверен, что наша дистанционная Zoom-конференция будет не хуже, а судя по представленным программам под секцией, уверен, даже полнее и лучше, чем все предыдущие. Вот. С этим я вас еще раз от лица деканата геологического факультета МГУ поздравляю и передаю слово уже нашему пленарному докладчику Владиславу Сергеевичу Исаеву, пожалуйста.
Добрый день. Сегодня мне предоставлена возможность продемонстрировать вам лекцию, которую мы готовили для Норвежского технологического университета в рамках международного проекта Frozen Canoe. As you see here, today we see the presentation which called Main Building Project in Russian Arctic, Some Problems and Way of Its Solution. When we talk about the Arctic, we have to know that what does it mean. In accordance with our new law about Arctic zone, this sentence meant following. It's a community of 9 administrative districts of Russia. As you see here, it's Murmansk, Karelia Republic, Arkhangelsk, and so on. It includes European part of Russia and as well Western and Eastern Siberia and even Far East. The main idea of this unity is to rise up with distance areas for economic and culture and ecology rise up, especially in the meaning of main task of Russian economy. It includes development of North Sea Way, exploration of oil and gas fields in this area, as well supporting of normal life of local people, indigenous people as well. As you see, this territory occupied by the permafrost, and it means that all activities which accompany exploration activity will connect with changing of environmental condition. So we have to know about it and main all for prevention of this changing and damage of natural resources and natural environment. From the other side, you see the density of population on this area. Most of these areas have less 0.1 person per square kilometers. It means that absolutely empty territories, but it doesn't mean that you don't think about the ecological and environmental safety of this territory. Here she is a person who responsible for this area. This is Yulia Rudenko, Kosaryeva. She's director of Arctic Development Department, and this department, as I said before, was formed in 2018. It's a new one department. Here's some information about the Arctic zone, when it was organized, what about this territory. As you see here, it's a huge territory, 4.0 million kilometers squares, and as well as land territory, it's a shelf zone, it's islands, and so on. As you see here, it's also information about glaciers, and it's covered 30–40% of islands in Novaya Zemlya and Severная Zemlya, and 80–90% for Franz Josef Land. What is why? As you see here, we have to know about the permafrost condition for this area, and in this map, obviously, indicates that it's territory with continuous permafrost. Continuous permafrost means that we have 90 or 100% of area occupied by frozen ground. What is frozen ground or permafrost? It's grounds which exist during 2 seasons without thawing, without melting. And this territory exists in frozen condition 1,000 years. And depths of permafrost exceed 100 meters, sometimes to 1 kilometer, if you talk about the north part of Yakutia, for example. What the problems which we could meet at these areas? You see here the list of impact geoprocesses in onshore geology, and most of them connected with freezing and thawing process, as you see here. It's accompanied by the frost cracking, cryogenic swelling, and especially thermocast, thermoerosion, thermosuffusion, solifluction, and thermoabrasion. And it's not all, because we have a combination of cryogenic process with process connected with erosion or weathering process. As you see here, there's some kind of this list of processes. In result, we receive these pictures which illustrate the coastal change rate. It means that the coast in Arctic zone is most mobile formation of the territory. It's destroyed or eroded by the wave activity, ice activity, activity of solarity, and so on. And this rate is amazing. You see here, the biggest one is from 4.5 to 8 meters per year. You see, it's a huge figures. If you compare, if you imagine your task for exploration of these areas, you have to know that after 10 years in the dangerous places, like you see on this map, like red points, you will lost 100 meters of coast. It's a big problem for modern constructors and explorators of these areas. As you see here, it's also some impact factors in coastal geology, which connected with compound and structure of grounds which we have to use for our aims of its exploration. As well, you see underlying geology and geomorphology. We have to know all about high frequency dynamic process, and also we don't forget about low frequency primary process, as you see here. What about forecast? Forecast for this area is not optimistic, as you see here. For example, B and C variants of changing of ice covering of south and north poles of the Earth show us that future of these areas will be connected with climate change process, and this climate changing here will be connected with rising of temperature, average temperature of air and sea water. It led to it will leading to their decreasing of ice covering, and from the one side it will let us to use seaway for acceleration of economy or logistic ways of gas and oil delivery to the Asian countries. But from the other side, we increase warm season for these areas, and means that wave activity, tidal surge, and so on will increase as impact on the coast areas, and our coast will destroy much more fast. Well, here's illustration of the main mechanism of thermal abrasion and thermal denudation of the coastal zone. As you see here, the main factors is wave activity, it's the ice content of frozen grounds, and properties of the mineral contents of these coasts. And as a result, you see these pictures. It's natural coastline in the Kara Sea, Badar Bay, where our students have the field work and could see this coastline erosion in situ. And on the right image, you see some kind of coastal changing in Arctic in Canada. Well, here's some main terminology sentence of this process, and you see here the connection between land and ocean. Mostly it's seas, and you see the difference between the zone of frozen ground and zone unfrozen ground in the onshore and offshore areas. But in Russian Arctic, this picture is much more complicated, because we have not so clear or simple structure of unfrozen ground in under the sea water on sea bottom, because we have a relict permafrost which could stay in some levels in seabed, under seabed, and we could meet it during the boreholing and so on, when we could exploit it on shore oil and gas fields. As well, here this is the illustration of the processes which could exist in the coastal zone, when we have a tidal crack, sea ice, ridge formed by grounded ice, and process which exist in the onshore zone with changing of depths of active layer and changing of coastal profile, when we have a pipeline inside of this area. And this big problem when we have a combination of sea and land condition for our construction. So when we have to go to the construction, we have to know about the some difference between them. As well, here you see the main differentiation of this. As well, you have aerial construction in onshore, in offshore, and linear construction in onshore, in offshore. As you see here, the list of this kind of construction. And when we talk about the Russia and areas which connect with Arctic zone, you have to see the picture which illustrate our gas and oil fields in the Arctic zone, on shore and offshore. And note please that Western Arctic zone is more researched or survived by the geologists and now exploited by the gas and oil companies. And future project connected with eastern part of the Arctic, but now it's just the future. Okay, let's go and try to know something about the main project in Russian Arctic. And first of this project, it is the Yamal LNG Foundation. And this is a huge project which was built due to consortium of Russian, Chinese, and French investors. And now it's the biggest construction in Arctic condition in the world, and it's working now and already exists. So you see the main preference of this project. On the right part of this slide, you see the North Sea route, which lets delivery LNG from the Yamal plant to the Asian centers in 15 days faster. It's the main advantages of this project. But this project has some problems, and as well the Novoport oil and gas field on permafrost. The main problems connected with the permafrost, first of all, because permafrost in this area is not so simple. As you see on the right side of this slide, you see the yellow areas on this profile or cross, and this, it means that these areas in this section not this parts of this section is salten. What does it mean for the frozen ground? It means that even if you have a temperature below zero, and it doesn't mean that the ground is frozen. It could be, and it is unfrozen. In this case, all construction which you will project it as for frozen ground with high boring capacity is not so. And it does mean that it means that your construction not to be stable and not to be so strong for carrying out all loads which will projected for this construction. For example, these tanks will have volume 160,000 cubic meters for liquid gas with temperature minus 163 degrees of Celsius. And you could imagine what the load will be for the permafrost basement for these 4 tanks. Now, there are a lot of problems how to preserve this big construction for melting or unstable condition of cryopacks or salting grounds under the pile field, which prepared for these tanks, and tanks already installed on this pile field. And solution you will see here on the right images is thermal siphons. Thermal siphons is devices which lets accelerate freezing of the underground layers and layers with high salinity due to the transfer of negative temperature from the surface to the ground. And as you see here, there's some citation from Vinci Innovation Award procedure, which was done for the constructors of this solution and these tanks for Yamal LNG. Another project is the Lineary project. It's Bolonenko-Ukhta pipeline. It's a 600 kilometers of pipeline from the Yamal Peninsula to the Ukhta city, which coming across the Baydara Bay. As you see on the left side, it's a coffer dam construction, which done for the coming pipeline from the sea bed to the land part of the polar areas. On the left low images, you see how it was built. As you see here, it's polar night, and it's the coldest time for this area when the temperature is below zero, minus 40 below zero. And it's the single time when you could make it without damage of huge damage of the environment. And it was done, and now it's working, but we have a lot of problem with lineary construction. And you see here some factors in engineering and geology which connected with exploration. First one is the corrosion defects and defects caused by change in the design position and position of gas pipeline. As you see some illustration how it's look like and what we have for the changing. It could be divided on some, it's some different ways of changing. As you see here, it's a surface section of the GP and sagging areas of GP, GP drawdowns and GP construction. And most of them could be found after the construction, but most of them appear as a result of its exploration, because we have to work with oil and gas with temperature, positive temperature. But all of these pipelines and construction sites exist on negative temperature grounds basement, and contact of them could be dramatic. Some kind of this scenario is already described there, and most of this problem connected with defects of insulation of the pipelines or crane construction, as well as for big construction on this pipeline of this installation, as well as compression station, because compression station is some small cities on the polar areas, and the main problem is connected with heating leakage and leakage of water in these areas. Well, when we talk about the other big project, it's construction of North Latitude Railway. This railway is a huge project which aimed on the connection biggest, greatest oil and gas fields with some centers of its changing for the ready products such as gas and I don't know, oil products for machinery or car industry and so on. Well, how it's look like? It's look like the lines which already exist, but added by the Gazprom railways for Yamal Peninsula on the upper part of these pictures and some new areas. The main aim of this project is to divide the delivery loads from the existing railway to the new one. And as you see here, we will increase summary loads to 50 million tons per year. Well, but it's a future, but now we have to know about the problems which exist already on these areas. As you see here, it's a railway on the polar Euro, and you see that this line is not absolutely plain due to the thawing and thermokarst or frozen ground under this railway basement. As well, you see here some problem with snow transfer because coverage of snow in this area reach some meters, sometimes 8 or 10 meters when the railway coming through the tunnel inside of the snow. These pictures from the Vorkuta region. And you could see that it's problem, it's real problem. As well, the problem exists with the exploration of this road construction. As you see here, the all water transfer under the railway is also frozen during the winter, and people try to exploit it in a really dramatic condition, and sometimes it's look like a catastrophe because when the spring flooding became to coming through the railway basement, it could be destroyed as well as it exists, and it's happened in last year when the Vorkuta region was absolutely cut from the civilization for some days due to the destroying of the single railway from central Russia to Vorkuta. So what we have to do? What's the way of solution? As you see here, it's some ways for this solution. It's a complex geotechnical monitoring and new technologies of permafrost stabilization, and some list of them. We propose to use cone penetration tests as a way acceleration of engineer surveys. We propose shocking ground freezing as a way of oxidational situation, avoiding of this, and usage of new isolation materials. How it's look like? You see some example of how we did it for the Gazprom pipeline from Bovanenko to Ukhta on some its local object, when we met with some kind of thermokarst along the pipeline in crane construction. For this complex survey, we have to do the UAV or drone mapping of this area. In result, we will receive three-dimensional digital relief model. It gets us some conclusion. After that, we plan to do the ERT geophysics. It gets us information about the thermokarst and permafrost borders of these areas. And we have also some ERT survey conclusion. And after that, we could make assumption of these profiles for making more precise research of this area. And in results, in complex with georadar research, we will receive some areas with changing of permafrost, and could make some notes how to localizate or making more precise prevention work for this area in this condition. So for this concrete site, we have to we found that main problem connected with spring flooding of this area, because the pipeline crossed the slope and the spring water coming inside of this pipeline and destroys the permafrost around the pipeline. So we have to do the calculation or modeling of flooding effect of this area and propose some solution or some measurement which could decrease effect or impact of this flooding. It was accompanied by the modeling of temperature regime in these areas. Oh my God. Well, as I said, CPT as a method which could be applied for this area is now more effective as existing methods. It's look like a probe with some sensors could get us information about frozen ground temperature, soil resistivity, specific soil resistivity along the lateral surface, soil pore pressure, electric resistance, and methane content. Here you see some documents which already exist for this method, and as well we could see some examples of its application for the north areas. As you see, the geography of this application is wide, from Salihard to Gedan Peninsula, Ob Bay, and Polar Ural. We have lack of time, so I will be much more faster. And the main story of these methods is ability to receive the parameters of the ground massive in situ, without laboratory research and spending a lot of time for delivery of these samples to the laboratory and back. Okay, next one is low temperature cooling of the railway basement. It's already exists in the industry, and it exists from last century and was proposed by Canadian engineers. And now we have some new way of this usage for accidental cases when we need the very fast freezing of the permafrost. And this case needs some new technology, and new technology is based on the nitrogen under the negative temperature usage, and it lets us to receive the very low temperature and very fast freezing around the thermosiphons, which also usage for this methods. You see some kind of this construction and where is it produced. And last things which I would like to talk with you is a new installation materials. It's also proposed by our engineering staff or our oldest professors of our department in geology faculty, Lev Nikolaevich Krustalev. And the main idea of these installation materials is decreasing influence of negative temperature in winter period and decreasing influence on permafrost salinity in warm period, warm season. As you see here, it's natural experiments which get the very good results, and it was approved by the geophysic, georadar research, and also it's a dynamic of is changing due to the insulation usage. And the main idea how it's work, and it's you know, it's leads to decrease of positive or positive temperature which coming from salinity as well. Well, and our conclusion is following. For area construction in onshore are crucial: salinity, geotechnical support absence, thermal insulation damage, and water leakage, as well for linear construction. And what we could to do for its avoiding its way of solution. First of all, thermal stabilization devices, correct thermal forecast on the base of geotechnical monitoring system, exchange of unconditional grounds, CPT survey in complicated cases, usage of nitrogen and LNG for accidental cases, for freezing stabilization, and of course geophysics. ART is the best for the engineering tasks. Thank you for your attention. Please, question. Спасибо большое за внимание. Если вопросов нет, то да, я с вами прощаюсь и приглашаю на сессии нашей конференции.